Hello, everybody. Welcome to another DevFest event. We are still in LLMWare Week, and we have like a very exciting event today. Last time, LLMWare took you on how to build RAG with their open source, and today they are going to teach you how to build agents. This is going to be super exciting. I don't want to take a lot of time from Darren, so just as we start, like always, I'm going to give you our giveaway form that you can submit. Remember, just take the form and add your GitHub handle. By the end of the event, you will just have on your dashboard a way to claim the prizes. We just cross-reference your GitHub handle and the one that you joined when you joined the event. So here is the link, just popping it up in the chat. And I'll put it a few more times soon because I see not everybody joined yet. So yeah, go ahead, Darren. The stage is yours.
Wonderful. Thank you so much, Nevo. And thanks everybody for joining today. Today really is going to be just awesome. I can't wait to share some things with you guys. And so whether you are a complete newbie, even if you've never programmed in Python before, even if you don't know what a model is, to if you're a complete prompting guru with lots of experience working with models, I think you're going to learn some new things, some new tricks, some new capabilities, and see some really powerful, but really simple and easy ways to start building up your skill set as it relates to some really cutting edge kind of recipes and examples using small language models and using agents. All right, so that's what we're going to get to. I think it's going to be awesome. Most of today's talk, I'm going to be walking through a couple of examples in the LLMWare repository. So I'm going to flip over in just a second. We're going to start looking at code. That's going to be most of the talk. Before we do that, I just want to set context just for maybe 1 minute, which is, who is LLMWare? What are we all about? So LLMWare is an open source project. We launched it almost exactly 1 year ago today. And the key premise behind LLMWare is how do you use small language models? And I'll explain what that is in just a minute. But how do you use small language models in open source to build really powerful language model-based applications, whether those are chat-oriented, which everybody is familiar with chat, RAG-oriented, which is really around retrieval augmented generation. How do you connect knowledge to a model? Or the topic that we're going to go through today, which is really around agents and how do you start stringing together multiple models and multiple functions to do more complex things using LLMs. I'll probably use the phrase LLM and SLM interchangeably. Again, what I'm really talking about are the kinds of AI, generative AI models that we're all used to. Now, again, one other quick kind of background note. What is a small language model? Everybody's heard of large language models. Everybody, hopefully on this call, has heard of an LLM. Really, the difference between them is just size. And again, if you follow the market closely, starting probably 3 or 4 years ago, models went from, call it 100 million parameters, being a decent-sized model, to where OpenAI took it with GPT-3 and DaVinci to 175 billion parameter models. So there was this massive explosion in the size of models. And they started getting great results. I mean, that was DaVinci, that led to ChatGPT, that led to this whole explosion around generative AI. And in the course of doing that, a lot of the large vendors, the proprietary API-based vendors, started creating models bigger and bigger and bigger and bigger and bigger. 100 billion parameter models, 200 billion parameter models, even some models that you use today over an API that are 1 trillion parameters in total across their architecture. Well, at the same time that this was happening, a lot of research was going into how do you make these models better? How do you build better training set recipes for it? How do you build better training data sets? And so there was all this improvement, call it in the underlying technology of how do you build a great model. And so all those companies, as they were building their giant models, started saying, why don't we take the same model architecture, the same basic training approach, let's just do it in a smaller size. That's where a lot of the energy in the open source community has been over the last couple of years. And you've seen this incredible curve of improvement in smaller language models. Smaller language models, we'll just define them roughly, from around 1 billion parameters to 10 billion parameters. Now, again, this is huge compared to where models were just 3 or 4 years ago, but it's really, really small compared to some of the large models today. Now, why would we talk about small language models? Because usually bigger is better, right? I mean, bigger is better. Why would you be using smaller stuff? And the reason is very simple. The cost and complexity is typically 1/100th to 1,000th of some of those large language models. And the performance difference for most tasks is going to be measured in incremental percentages. So in other words, that 10 billion parameter model, let's just say it's 10% worse or 20% worse. The difference, though, is when you take that model and you apply state-of-the-art quantization techniques, you can run that model incrementally at zero cost because you can scale it all the way down to edge devices, laptops, and commodity servers. There's a comment, actually, SLMs are better for fine-tuning, and that's absolutely true. The other dimension of this is those large language models that many of us have worked with. They're really, really expensive and complicated when you want to fine-tune them. So if you want to improve a process, it becomes actually really hard to do. You get great results. You're really, really excited when you first run that test script, like, wow, this is going to be awesome. But then what do you do when you actually have to start adapting it? The fine-tuning process of those models is really, really complicated and expensive. SLMs, you can fine-tune typically very quickly and at very low cost. All right, so that's a quick sort of primer on SLMs, but let's see them in action. As I said, let's get in and let's flip open to the repository and let's spend the rest of the time really showing you some of the examples in the course that we have in LLMWare. Let me flip over. I am going to show my whole screen, which hopefully will be okay with everybody. Hopefully it's going to be clear. All right, just a quick check. I hope everybody can see the LLMWare GitHub page. If not, if somebody could please just shout out and say you can't see it. This is the LLMWare repository. And I'm going to walk through one tab in particular, which is Fast Start. And what
just a quick note, Darren, one quick note. Because you have a little bit wider screen, if you can just like zoom it a little bit in, it will be a lot easier for people to see what's going on. Yeah, perfect. Yeah.
Good. Yeah. Okay, good. Thank you. This space has evolved so fast. Again, even if you're following it every single day, it can be completely overwhelming to try to track what's going on. And so what we found is there were a lot of people who wanted to get started with LLMware, but actually wanted to be able to do it in a much more structured way to be able to learn from examples. And so we created 2 different Fast Start series. Again, hopefully it's clear from the screen. The first one is RAG. Now, we reviewed this on Monday. If you were part of it on Monday, great. But I'll give you, again, a quick 30-second update for those who weren't on the call. And I'd encourage you to go check out the video link. What we reviewed in the first Fast Start was really this whole idea of retrieval augmented generation in depth. How do you connect knowledge with models? And at its core, that's what retrieval augmented generation is, or RAG, is all about. And so a huge part of that is actually the heavy lifting of how do you unpack and deconstruct and parse and extract and text chunk and retrieve information that in some ways is trapped in a bunch of legacy, unstructured, heterogeneous document formats. How do you extract all that information in meaningful ways so that then you can assemble components of that information and draw on it in creating prompts with LLMs and then get fact-based answers? That's what Monday's talk was all about. Even if you weren't on the call, I would encourage you, go check out the RAG series. It's a set of guided copy and paste examples that really walk you through all the building blocks, all the skills to really get started and doing some really interesting things using retrieval augmented generation. So that was what we covered on Monday. But today's topic is all about agents. And I'll just say today is definitely more fun. So you tuned into the right session because agents are all about models, and models are really fun to use. And there's nothing more exciting than when you actually start pulling down a model, you're running it in your local environment, completely kind of in your operating environment, and you can start running inferences and seeing really good high quality results. And that's what today is all about. So hopefully you'll listen to what I'm saying and then start running these examples. But I also won't hold it against you if you want to just go to the repository and start running some of these examples while we're going on the video. But the punchline, in the next hour, even if you've never touched a model before, you should be able to locally start running inferences on whatever machine you're using to actually watch this video. So that's sort of the premise of today. Now I'm going to take a minute, and again, I'll sort of walk you through what's here. You can see there are 15 examples. Each one is self-contained, so you can go through and use each one if you want to start out of order. But they're also designed in a nice sequence, just to make it easy to step by step to start building up your skill set in this area. Now, if you've not yet done this already, how do you get started with LLMWare? And I'm going to try to move the screen a little. I don't know if you can see it, so give me just a second. Okay, hopefully that's pretty clear. There we go. Okay, how do you get started? You can either clone the repository, which we would recommend in most cases. When you clone the repository, you get all of the examples. So it's really easy. If you prefer to pip install, you can pip install LLMWare. Please make sure you're pulling the latest version, which is 0.3.7, which you should get automatically, but it's good just to check to make sure that that's what you're actually getting in your environment. Once you clone the repository, there are 2 welcome scripts that we provide in the root folder. If you're on Mac or Linux, run the welcome to LLMWare. If you're running on Windows, run welcome to LLMWare Windows. All that's going to do, it's going to install some of the dependencies. It's then going to pull out some of the examples and put them in your root path. So if you are working from a command line, it's really easy then to literally just start running some examples from the command line. Supported platforms are all sort of the big ones. So if you're running on Mac, you're running on Windows. If you are running in a Linux environment, Ubuntu 20 or Ubuntu 22 are preferred. So please keep that in mind. And in terms of RAM, it really does help if you have at least 16 gigabytes of RAM in your environment. We'd probably recommend 32. You'll get faster performance, and there will be some larger models that you can run with 32. They're going to be pretty painful to run with just 16. And again, anything Python 3.9 and up should work. All right. I don't doubt there's anybody on this call who's not heard the word agent, but I'd also probably challenge anybody in this call to say, what is an agent? Agent has become probably the most overloaded term in generative AI. Everybody loves to talk about agents, but they mean a lot of different things by the word agent. I'm going to give you a very simple operational definition, which is right here. Part of the reason people are talking about agents is simply moving past chatbots. For so many people, their introduction to generative AI was ChatGPT. It was a chatbot. And a chatbot is so intuitive. It's very, very powerful. You write something, you get a response. It's just like chatting or texting with somebody. So it's an incredibly powerful interface and use case. Agents are really the bridge to doing more with generative AI than just a chatbot. Now, why would you want to do that? Because we've all used chatbots. They're pretty effective, and you can do a lot of things. You can copy and paste, and you can chain together conversations. Like, why would you want to move beyond chatbots? And to some degree, again, this ties into why agents are important. It's moving beyond just an interaction that you might want to have and starting to think about how, in effect, you can start converting models into code so that you can start stringing together maybe multiple calls to a model, maybe multiple other functions, analyses, extracting information, other transformations that you may want to use, a web service that you may want to call, and stringing it all together so that model is just a tool. It's just a tool or yet another function, another line of code that you might want to be putting together into an overall pipeline that you're building, seamlessly integrating all of these capabilities that an LLM and a model can bring. And at its core, that's what we see an agent really being about, and that's what we're going to start to walk you through. All right, here is an overview of all of the examples. All of them are in this repository. Again, I'm going to flip them open so we can get in and start, looking through them. I would recommend just to everybody, we all like to skip steps. We all like to go really, really fast. What I would just encourage you to do, just to get started, is walk before you run. Make sure that everything is installed correctly. Make sure that the basic test and the basic script is working. And then start running and adapting and improvising and building up, whatever it is that you actually want to do with it. And so in that spirit, the first script that, again, we're going to kind of start to walk through is a start here. The start here script is actually going to walk you through basically the formalism in LLMware, which is really, really simple, and kind of those magical, like the 2 or 3 lines that you really need so you can load a model and start running inferences and getting responses out of it. So we're going to walk through the start here. The second one then shows you a whole bunch of different models that, again, you can just start sampling, running those models and running some basic prompts with those models. The third and fourth example show you 2 of the most useful things that you actually want a model to do. Again, for all the talk about, well, models, I want them to reason and solve problems and, do all this, complicated kinds of things. One of the most useful things is basically extract something, because I don't want to read that. That passage maybe is really complicated or really difficult. I just want you, the model, please pull out a couple of key data points for me so I don't have to do it. So we see extraction as one of the most valuable kind of programmatic tasks that a small language model can perform, and perform really well. And then the second one, which is summarize, which is, again, same kind of idea. God, I don't want to read these 2 pages. It's really long and hard and complicated. Can you please just net it out? Just give me a few bullet points. And so we're going to talk about those 2 function calling capabilities, extraction and summary. And then we're going to get in example 5, we're going to start putting all of this together and showing how the abstraction of an agent can enable you to do some incredibly powerful things, orchestrating multiple different models, doing it all locally, and doing it with the simplest possible code that you can imagine. And then from there, we really get into really cool and fun stuff. We give another example of a multi-step agent process. If you haven't done local voice-to-text transcription, there is nothing more fun than that. Again, you can get started. We provide a whole set of sample WAV files that you can pull down in a minute and start doing voice transcription. Again, 100% locally, 100% privately, 100% running on your machine in a few minutes. We provide, if you're a big fan of Phi 3 from Microsoft, which in all of our testing, we think is pound for pound, probably the most effective and accurate small language model. We built up a whole series of function calling fine-tunes on Phi 3. What about summarizing longer documents? I think we've all done this at some point. Sometimes it works really well and it's awesome. Sometimes it works terribly, which is you have like a long document, like a 20-page document, and you ask for some kind of summary. Well, with smaller language models, we actually have a methodology to chunk up that document, break it up into a few different pieces, call with the model, page 1 and 2, page 3 and 4, page 5 and 6, and then assemble the whole thing. What about semantic similarity ranking? Again, a really, really cool and powerful technique. You ask a natural language question to a complex document. We show you in less than 10 lines of code how you can use a semantic re-ranker combined with a small language model to start putting those pieces together, 2 models working together to ask a question to a larger document and start getting answers. We show you how to do some streaming, a complex scenario using web services. I haven't even gotten to probably the most fun and interesting thing, which is text to SQL models. So ask a natural language question, the natural language question paired with a table schema converts that into a SQL query that then can be run against a database. We show the end-to-end workflow of how to do this all on a local machine using SQLite. And then some tests. We actually published a RAG benchmark test because one of the most common questions we would get from enterprise customers was like, how accurate is this? I don't understand what all these like model, abstract scores are. Like, is it going to work or is it not going to work? And so we created a test. So again, really, really easy if you want to start scoring and ranking, a particular model. And then we've even integrated all the models that we've tested, which is around 27. We've integrated those test scores into LLMWare. So even as you're discovering a model or starting to use a model, you get a sense of, hey, how accurate was this model? How does it compare with another model? All right, so tons and tons of stuff to get through. I am going to keep going. If anybody has a burning question, please shout it out. Otherwise, we're just going to keep pushing ahead. We're going to dive into the first example. All right, let me spend a second just to adjust this. I hope everybody can read this. If not, and you want to just read this on your local screen, again, LLMWare Repository, fast start agents, and this is the first example, the start here entry point, okay? All right. All of these examples we annotate with a lot of comments. And again, it really starts with the premise you don't know a lot about models, you don't know a lot about LLMWare. We want this to be completely self-contained. So you copy and paste this, you should be able to use this then to do everything that you need to get started to be able to run the example. All right. As I mentioned, first things first, either pip install LLMWare or clone the repository and then follow that welcome to LLMWare script. Once you have done that, we are ready to get started. Now, if you just copy, paste, and run, the only thing I want to let you know, I guess, are two things. First, the first time you run the script, these models are going to be pulled from the LLMWare repository on Hugging Face. Those models are going to be downloaded and cached on your local machine. So the first time that you run it, it probably will take, for Bling Answer Tool, a 1 billion parameter model, depending upon your network connection, probably 20 to 30 seconds. For some of the larger models, it might take a minute or two. If you're downloading a really, really large model, obviously it can take several minutes to download and cache that model on your local machine. But once you've done that once, it's a one-time penalty in terms of time. The next time that you run the script, it'll pull from your local cache. And so it'll be much, much, much faster. So typically it'll take 2 to 5 seconds the next time that you run the script to load that model and to start running inferences against it, okay? The second thing that I wanted to let you know is, where are those models? The models, they're just binaries. It's just bits. Those bits are going to be in your home directory path. You should look for a folder path called LLMWare Data. Within LLMWare Data, you'll see a model repo. And within that folder path, you'll see folders then for each of these models. So they're just math functions. Math functions instantiated in binaries. They will all be on your local machine. So you can look at them, touch them, you can move them around, you can run experiments with them, you can delete them anytime that you want. But that's where these models will be cached once they're pulled down. All right, let's get into the fun stuff. So first thing that you need to do is just an import of LLMWare models. Model catalog is one of the key abstractions that you'll wind up using a lot in LLMWare. And it's intended to be just that, a high-level interface, a powerful abstraction that at the end of the day, you have a set of models, all of the implementation details, the configuration details of those models, all the gorpy stuff around it, you shouldn't have to worry about when you're just trying to get something done. So the model catalog is what manages a lot of that underlying complexity for different types and classes of models to expose the simplest possible interface for discovery. All you need to know is the model name. If you know the model name, all you have to do is load the model from the model catalog. And so what we're going to do, the very, very first example, the hello world, the most boring prompt ever written in the history of the world. You're going to load a model. I'll explain the model we're going to load. It's the Bling Answer tool, which is a 1 billion parameter tiny llama that we've fine-tuned for fact-based question answering. So it's going to assume some context passage is passed to it. And then we 4-bit quantized it using Llama CPP and GGUF. That's the Bling Answer tool. We're going to load that model, and then we're going to run our first inference. And the model, all the models expose an inference method, they expose a function call method, and they expose a stream method. And we're going to talk a little bit, we're just going to get started with the inference method. And the prompt we're going to pass, again, it's hello world. It's not exciting. I don't think anybody should be too excited about seeing this. My son is 21 years old. He actually is 21 years old. And then we're just going to ask a very simple question. How old is my son? And then we're going to print the response. Now, when you run this first example, as I said, you're going to see 30 seconds to a minute delay as the model is being downloaded and cached on your local machine. It'll take about a second to actually run the inference. And then you'll see, again, the most boring response ever of that your son is 21 years old. And then you'll see some of the other metadata that are provided in that response. The goal of this is once you've done this, you have a very simple and easy to use recipe. If you don't want to go any further with any more code or examples, to create a basic inference, pick a model, enter in some prompt, and then you can print out and you can get the response. So hopefully, as soon as this call is over, whatever time zone you're in, within 15 minutes afterwards, plus 15 after the end of this call, you can have actually run your first inference using LLMWare running all locally on your machine. All right, so that's the first very, very simple example. Now, there are a lot of optional configuration parameters that you may want to use so that you can start controlling or configuring what the model generation is actually going to do. And again, they're very, very simple parameters. They're optional, so you don't have to use them. If you just want to get some simple and basic stuff, don't even bother with them. But what we're seeing here now are just some of those optional parameters in the load model method. And the parameters that we're going to use here is we're going to set temperature to 0 and sampling to false. Now, you might ask, what the heck does that actually mean? Well, if you've used any kind of model zoo or model garden, certainly you've adjusted the temperature setting. And typically, large models, they recommend, hey, set the temperature because you get more interesting results and you're going to get mixed, variable results and all that. Well, one thing that we've actually found is that process injects a lot of the randomness and problems that people have with LLMs. So, most of you probably remember, there's been some high-profile stories where, Google at some analyst event, they run some test, right? They have their big executive up on stage. They're going to show how awesome their model is. They just ask one question, and it gives the wrong answer. And you're like, how could that possibly be? Most of you, whether you're in school or you're working, people prepare that stuff. So how could the smartest people in the world at Google, probably preparing it 100 times, how could they have given their executive something that would turn out to be wrong? Well, it's all because of this. So we actually published a video on this topic that I'd encourage you to go check out. More generally, check out our YouTube channel for LLM, where we have a whole bunch of different videos and tutorials. But temperature and sampling are actually injecting a stochastic or random element in any type of generation. So the short answer is those people at Google probably were very, very prepared, but they weren't careful and they didn't set this temperature setting to 0 and sampling to false. And so when the executive ran the script probably perfectly, it had some randomness. Each time they ran that script, it could give slightly different answers. And every now and then it would give wildly different answers, and it led to a wrong answer. So what we actually recommend, if you're actually trying to use LLMs in a programmatic context for a fact-based outcome, if you turn sampling off, turn it to false, then the answer is deterministic. What I mean by that is given the exact same input, exact same, you will always get the exact same output out of that model. And so it's very, very useful. If you have to give a demo, you have to give a school project, make sure that you turn sampling to false, because then you actually know the script that you're preparing, you're going to get consistently the same output. This won't solve the problem if your input is slightly different. If your input is slightly different, it is possible sometimes that you will get slightly different or even very different output. But if your input is exactly the same, you'll get exactly the same answer. So it turns off some of the most unpopular activity, right? Which is when an LLM starts making things up or deviating from a script or saying, where did this come from? You will get the raw output from the model, good or bad, but it will be consistent every single time if you turn sampling off. And then for this example, we just turned the maximum output, like how long is the output generation, to 200 tokens. So now in this example, we've just configured it that way. Again, another pretty boring hello world example, but just to show how you can start to build this up. Simple text passage. We've now separated out that context from the question that we want to ask. And we again call our inference method on the model. We pass the prompt, our question, and now we say we want to add a context passage. That context passage is our text passage. Again, we run the response and we print it out to the screen. All right. Now, if you've done this, again, within 15 minutes after the call, hopefully you'll have completed both of these, and you should be off and at least walking pretty fast of using this stuff. But now, again, step by step, let's just start to build up some additional skills and capabilities. Because you might be asking one key question, which is, all right, that's great that you showed us 2 model names, but where do we get all the model names? What models are available? This looks really easy, but if we don't know what the model names are, how are we supposed to use it? So the model catalog exposes a very, very simple method. In this case, list generative local models. This is going to print to your screen a long, long list. I think it's going to be almost about 150 models. And we're adding all the time. In fact, we're going to be dropping a whole bunch more in the next week or so. But I think it's going to be about 150 models. And each model is basically a little dictionary entry. And you can just pull off that model, the model name. And as I said, once you know that model name, you can just call and start invoking that model. So this gives you a view then of all the models that you have that kind of point and click, extract that name, and then you can start to use. Now, I'm not covering in this example, but we have a bunch of other examples. It's really easy to add models to your model catalog. If you don't see a model that you want to use, it's really, really easy to create a new model card, register it in your model catalog, and then start to use that model with the same really simple interface of just representing that model by its name. Okay. Now let's layer in something a little more interesting and start to get a little more complicated. One of the most powerful capabilities, something we really, really believe in, is this whole idea of function calling models. And the basic idea is you want to use the model as a tool. Again, read this and analyze this for me. Read this and extract a key piece of information. Or in this case, the very first example, we're going to do something that's very intuitive, which is sentiment. Read this passage, read this paragraph, read this, customer review, read, a piece of a voice transcript of maybe a call center, like your transcript that came in, read it, and then basically help me understand, like, was it positive? Was it negative? Was it somewhere in between? And oftentimes it's that polarity. Hey, if it's negative, I want to do one thing with it. If it's positive, maybe I want to do something different with it. So oftentimes in a workflow, this is basically one of those key if-then kinds of decision points. If it's this, then go down one path. If it's not, then go down a different path. So we've built out a whole set of fine-tuned, small, specialized function calling models. And the way that we've implemented this using small models, recognizing that a small model probably can't do everything, is we've turned them into specialists. So there are 20 different slim models, and they're just that. They're slim, they're small. They're SLMs, and they're structured language. With structured language, what we mean is that these models don't output pure text. They output Python objects. So for the most part, they output text in the form of a Python dictionary. In some cases, it's a Python list. And then also programmatic outputs, like directly generating SQL out of it. So structured outputs, single purpose specialized tasks. Now, how do you start using these SLIM models? Well, the same way. Load model, load SLIM sentiment tool. But now, instead of calling the model with inference, we're going to call that model with its function call method. You call that model with function call, we're passing in, again, a hello world, a really simple, really boring little text passage to read. Negative, right? Negative, worst earnings call ever. What a disaster. And then all you have to do is print out the response. Now, what's pretty cool about this, you might say, you could go do this on a lot of models. But what happens typically if you do this? Typically on a larger model, without any prompting and instructions, I mean, look how simple the code is. This is all there is to it. There's no magic happening behind the scenes. This is the code that's being run. If you do this with a larger model, usually the output that you're going to get is something like the following. Sure, I'd be happy to help you with that. Sentiment is a really important way to look at a piece of text. You sent me the following text. I believe that this text should be properly classified as positive. However, you should look and evaluate it because I'm just a model. There can be a subjective opinion to this. And then a whole bunch of other English, right? Talking about all the qualifications and hedges about, well, it might be positive, it might be negative. Here's some words that I thought might be positive or negative. Do you want me to look at anything else? It's long and it's kind of hard to deal with programmatically. All I want to do is a simple check on this. If it's bad, I want to do one code path. If it's good, I want to do a different one. And so the magic here, and when you run this little script, what I'd really encourage you to do is look at line 87 and line 88, because it's really cool. What actually happens is the model has been trained to generate a Python dictionary. And the Python dictionary it's going to generate has one key, sentiment. And it's going to have a value for sentiment that's put in a list, so in square brackets. And that sentiment is either going to be positive, negative, or neutral. So the beauty of this tiny little model running locally on your machine, you don't have to get into any complex instructions or parsing. This response, LLM response sentiment, can actually be pulled up and it can give you the answer that you're looking for. So you can start building it into a programmatic script. And you can start saying code that actually seems pretty sensible, like if response, LLM response, sentiment equals positive, then do this. If it's negative, then do that. And so we have a whole bunch of examples that actually show you how to build out that simple logic. But again, think how powerful that is as a tool to start running a function call, simple, clear, declarative code to start getting those kinds of classification decisions. Now, hopefully that pattern starts to make sense because it's a pattern that you can repeat then across multiple different functions. So sentiment is a really, really useful function call. Another super useful one, as I mentioned earlier, and we have a whole example on it, is extract. Just pull out some numbers for me or pull out an answer to something because I don't want to read it. And here's a very representative example of that. We use some of these in our examples. Earnings press releases, right? If you've invested in a stock, you see that earnings press release, and what do you want to do? You want to immediately tear into it. Say, okay, well, what happened? Was it good? Was it bad? What did they announce? If you're a financial analyst or a research analyst, the first thing that's going to happen is your MD is going to send something to you. Here's the link or here's the text. Summarize the key points, extract the information that we always care about, and get it ready to start updating our model so we can quickly assess the impact of this. But now look at it. There's a whole bunch of numbers and data points, and it can hurt your head having to systematically extract and compare all of these things. Wouldn't it be great if an LLM, we could just pass this passage in and say, I just want a couple pieces of information. Just share directly the answers to those information. Well, that's what the SLIM extract tool is all about. It is probably my personal favorite model. It's the most useful model because it does the biggest thing that we think LLMs do really, really well, which is extracting information. Read this, pull out a couple of key data points, and give it to me in a format that I can then quickly integrate it into something else. So again, at this point, it's boring, right? 40 minutes into this talk, and you're like, man, load model. Yeah, that's super easy. I know how to load any kind of model using LLMware. Again, we're going to use our function call method. And now we're going to expose a couple more of the optional parameters, which gives you a slightly deeper sense of what's actually happening and how to use these models. We're going to pass in our text passage, that earnings release. The function we're calling is extract. And now the parameter that we want to pass, this extract function, is revenue. So extract for us the revenue value. No other complex instructions or prompt values, no text that you have to write.
Darren,
You are a good and
a quick thing, you're not sharing your screen anymore in case you were sharing something.
Oh. Hold on. Okay, am I sharing again?
Yeah, you're good to go.
Okay, you can see my screen?
Yeah, it's visible.
Okay. And we're on line 100.
If you can zoom in a little bit, it would be good, but
yeah, let me see. I'm so sorry. Let me see. Trying to make it bigger without zooming out completely. Okay, is that good?
Yeah, all good.
Okay, awesome. I'm gonna scroll over just so you can see the line numbers. Actually, can't. Okay. So as I said, and hopefully everybody was following, even if you couldn't see the screen. We're gonna look at this text passage. We're gonna load an extract model. We're gonna make a function call. The function call, we're saying, extract the revenue. That's the key thing we want to know out of this. All these data points and numbers and stuff, get the revenue. That's what we really care about. And then you're going to see, just print out the response. You get a really nice dictionary. The dictionary has one value called revenue. And then it's going to give you the value of the revenue in a list object. So again, it becomes really easy to programmatically pull out that value and start integrating it into a more complex workflow. All right, now at this point, you guys are old pros in seeing how this works. We're going to load a different model, a topics model. What this model does is it actually generates what is typically a 1 to 3 word distillation or summary of what is this passage about, which oftentimes is really, really useful when you want to classify or cluster. Sometimes you don't even want to know a lot of information about a passage. You're just like, hey, tell me sort of which bucket it's in, or in 1 or 2 words, what is this thing about? That's what the topic function calling model will do. Again, really simple, same formalism. You load the model, function call on the text passage. In this case, the function is classify, and the parameter that we're passing is topic. Again, you can see the output. We're going to do the same thing now with tags. Tags is a really cool model. We actually stumbled into it through experimentation, but essentially it's going to generate the most meaningful objects that are found in that passage. So it could be named entities, it could be numbers. Sometimes it might be a really meaningful clause, but it's actually going to give you a list of actually those key points, those key tags that were in a longer passage. And again, same formalism. You load the model, you run the function call, and you start extracting it. Now, keep going through this with a whole series of different models. And then we wanted to show you, if you want to just run through a whole batch, you can run this tool test run. This is going to pull the model. It's going to pull a test set that we include with the model, and you can actually see the whole thing unfolding before you to give you a really good representative view of what those models are doing. Now, a couple of quick backgrounds before we pivot to the next example, before we start getting to some really, really interesting stuff. Function calling models, what we've done on this page is we've introduced them with a very, very simple formalism directly on that model object. We also expose them as prompts. So in a prompt object, which is what we covered with RAG, you can start integrating knowledge then and building really complex prompts using these models. And then we also have what we call an LLMFX class, an LLM function calling class, which is typically how you construct agent processes. And that's the example that I'm going to get into next, where your agent object makes it even simpler to start invoking and chaining together a lot of these SLIM models. Now, the last thing that I wanted to highlight here is just about all the models that we've used on this page. And again, if you run through this example, you've worked with like 10 different models, again, in 15 or 20 minutes. Most of these models have tool at the end of their name. That typically means that we've packaged these models as Llama CPP, GGUF models, and they're going to run really well in either a Mac environment. They'll run really well on a CUDA environment. They'll run really well if you're using like a Google shared collab space, like on a T4. They'll work really well if you're running on like a gaming laptop. What they're not going to run great on is actually Windows machines. So if you're using a standard Windows, Wintel type of laptop, we would really encourage you, after you've gone through some of this, check out the examples we have on OpenVINO and Onyx, which are two other low-level inferencing model packaging technologies that are highly, highly optimized to run really fast on Windows machines. And again, this is a huge area for us. So you're going to see a lot of announcements from us. You're going to see more models in this format, because we think if you are, like a lot of the world, using Wintel machines, this is actually the ticket to really unlock some of the performance. So everything we've just shown you, it will run. Absolutely, if you're using a Windows and a Wintel machine. But if you want to run it even faster, really pivoting to the OpenVINO versions of those models and the Onyx versions of those models that are in our model catalog are going to enable you to do it much faster. All right, so that was example one. And again, I hope, as I said, if you've never done any of this before, hopefully that gives you a really good starting point, step by step. And even if you've done, again, if you're a prompting guru, hopefully that's something new, some new tricks and some new capabilities that you can start integrating in the way that you use models. Now we've got 15 examples here. I'm not going to be able to go through all of them. I've highlighted, given you a quick overview of them. In example 2, I'm going to skip over this one. This one really ties into the RAG course that we went through on Monday. It shows how to start building prompts, and really, really easily. Same thing. In one example, you have right at your fingertips the ability to run like 15 different fact-based question and answer models, and really run through a whole series of questions just to see how they work. The Slim Extract model, a whole bunch more examples to show how easy it is to start extracting cool information in just 10 lines of code. Likewise, how to create summaries. Our summary function call, we actually implemented a little differently. We implement our summary as a list of key points. The benefit of making it just a pure list object is it becomes really easy to start concatenating and stringing those together. Whereas if you have bullet points and all these other sort of formatting and numbers, anyone that's ever tried to add two unstructured lists before knows what a nightmare that can be. So our summary doesn't output any of those formatting things. It's just a pure Python list. So you can also quickly interrogate with code, how many points did the model return? And it becomes really easy then to just assemble and concatenate those lists if you're trying to create a more complex summary across multiple different function calls. All right, now the example that I wanted to show you, you've got 10 more minutes left, but the example I had to get into is I wanted to jump ahead to example 5, because this is where it gets super, super cool. Let me blow it up. Again, I hope everybody can see this. All right. I want to introduce, as I mentioned, how you actually start building agents. Because if you're following everything we just went through, that's actually the complicated way to do it. The simpler way to do it is using our LLMFX class. And what this gives you is an integrated mechanism to start referring to models simply by their capability, It conceptualizes those models as just a tool. And then the code that you write is very simple, declarative, kind of functional code in which you ask an agent object, you run it through a bunch of work, you run it through a bunch of analysis. All of the journaling capability is fully integrated. And so you'll see it in a really nice, really cool way I'm displaying on your screen. And then you can generate a bunch of really useful summary outputs at the end. And this is all the code. I'm going to walk through what this does. Sorry, there's a little latency on the screen, so hopefully you guys aren't seeing that. Okay. So here's the code. We create an LLMFX object. We're going to load some work. The work is just a big chunk of text. Chunk of text is a customer transcript. Then we're going to load a bunch of the tools, and we show a few different ways that you can load it. That's actually calling the load model that we just saw. Here, it's actually using a shorthand, a lookup table, where we've registered these specific functions as tools. And then it does that cross lookup of the longer model name, which you can configure so you can mix and match different underlying implementations of different models. But all you have to do if you want to run a sentiment analysis, you just have to load the sentiment tool. Once you've loaded all those different models, what we really want our agent to do is, hey, think about running a whole bunch of different analysis, classify this piece of text, answer a whole bunch of analysis for me, and just give me a consolidated Python dictionary as an output. So we've loaded our work, we've loaded the models, the tools, and now each one of these simple little lines, agent sentiment, agent emotions, agent intent, we show different formalisms then. If you want to call it, you want to execute a function call, you can actually do it that way. If your code, if it's easier to basically pass a variable name of what function you want to pass. If you want to run multiple function calls, you can string them all together. But what's actually happening under the scenes? The agent has loaded that piece of work. So that's what it's looking at. That's what it's trying to do. It's again going to automatically run all of these function calls against that piece of work, capture all of that state mechanism, and then give you a really comprehensive journal explaining what it's doing as it's going. Then there's an answer tool. So we're going to actually ask a free-form question. What is a short summary? We're asking to ask a question, what's the customer's account number and username? In this case, we're going to assign these to a key of customer information and summary. We can unload those tools. So if you have any issues from a memory point of view, you can actually formally pull them out of your memory space, remove any ongoing links to those. And then at the very end of this, we want to show the report. We want to see what the agent's done, all the activity summary. And then at the very end, we're just going to print out and display all this and then provide it as an output. The last thing, again, this is a totally self-standing example. Copy, paste, and run. Again, as I said, the first time it's going to download and pull all these models. So you might see a delay of 3 or 4 minutes the very first time that you run the example. The next time you run it, it'll take a few seconds. And it's going to operate on just this very simple customer transcript. You could picture this customer transcript might be extracted from something else. So it could be a voice transcript. Look at one of the examples on that. But here we've just reduced it to a piece of text. That's what we're going to pass into our agent. That's the agent's work. Go read this and go systematically extract all that information in those questions and then give it back to me as a programmatic Python dictionary. That Python dictionary, you could then pass into JSON and expose into another program. You could push it into a database where you could seamlessly integrate it into then a more complex process. All right, so I wanted to get through this example. Again, this shows you how to start building these agents by stringing together models to do really interesting work. Hopefully, again, if you've never even used Python before, this gives you an example of how easy it is. And again, hopefully it's given you a real flavor for the power of what can be done. We've just shown 2 of these 15 examples. A lot of them include end-to-end work examples, other models. And then once you're done with this, then what we really encourage you to do, hopefully the screen's okay. That's just the Fast Start series for agents. We would encourage you, go back and look at the Fast Start course for RAG. And once you've gone through those, go to town on all the examples that we have in the LLMWare repository. Most of them are just like the ones we've looked at, annotated, clear examples. They build up skills case by case, from end-to-end use cases, UI, incredibly cool things we didn't get a chance to get into around structured tables, exploring other models, different retrieval and database strategies. If you like notebooks, we've got a whole bunch of things on notebooks. If you like parsing and extracting information from documents, whole bunch of stuff on that. So again, would really encourage you to kind of dive in and use these examples. And again, I would think in the next couple of hours, if you wanted to do this, you could probably work through probably 10 or 15 different examples and really build up a whole new set of skills using LLMware. All right. So sorry if I went through this in kind of a whirlwind kind of fashion, but we had a ton of stuff that we wanted to get through. And I wanted to make sure that we walk through it with some depth. So again, thank you, everybody. We'll pause here. I think we've got 2 or 3 minutes. So we'll pause if there are any open and burning questions that people want to ask.
Okay, we have a few questions here. Somebody asked, are all these models around 4 megabytes, the small ones?
It's a great question, and that's evolving all the time. So small language models, I would say operationally, range from about 1 billion parameters, that's the smallest, up to, again, you'd probably stop it at 9 billion. There's some 12 to 14 billion parameter models. That's probably the range, and it's a wide range. Now, those models are almost always 4-bit quantized, meaning the actual size, like the binary that's going to be running on your machine, is typically about half of that. So for a 1 billion parameter model, it's typically in the 600 to 700 megabytes. For a 3.8 billion parameter model, like the 5.3, which is an awesome model, it's going to be a little over 2 gigabytes. And then if you're all the way up, let's say you want to use the Quen 14B, which we've been doing some experimentation with, that's going to be probably 8 to 9 gigabytes. So again, a good rule of thumb is it's probably going to be a little more than half in gigabytes, the number of billion parameters of the model.
All right, cool. I don't see any more questions. So thank you so much, Darren. And yeah, we're going to move now to the giveaway. Thank you so much.
Awesome. Thank you, everybody.
All right, I already prepared a giveaway. Just to let you know, I didn't put the giveaway for all the people. It's only like something like a little bit after half of the event, because I want to minimize the amount of people that just trying to exploit the event for swag. So really, if you want swag, join from the start and have the link. It doesn't matter if you get the link later, because you will not be in it after half of the event. So please join in from the start. So let me share my screen. Today we're having 2 giveaways. That basically means that I'm going to roll the wheel. I'm going to get 2 people. Those 2 people, I'll ask them here on the chat if they are here. And then if they are, I'll mark them. And by the end of the event, they will have the ability to claim swag. Basically, the GitHub handle that they put here in the spinning wheel should match the one inside of DevFest, basically. So that's it. Let's spin it, and good luck, everybody. Again, if there is a duplicate, the person will be disqualified. So please don't put any duplicates. Okay, we have Dhruv Janakala. Let me just check that you are one time. Yep, one time. Are you here with us on the chat? Dhruv Janakala. Are you with us? Ah, okay, you're here. Perfect. All right, cool. Marking you here. All right. Next spin. Deroy. Deroy, are you here with us? Real name on GitHub? Nothing. So don't know even how to confirm that it's you, but are you here on the chat? Adire? Adire? Are you here? All right, he's here. Okay, perfect. So I've already explained how you can claim it. So let me mark you as here. Let me see that you are really only one time on the wheel, that you didn't cheat. Let's see. No cheating. Okay, you're only one time. Perfect. So thank you very much, everybody. And I will see you next week with our next sponsors. Please go ahead and don't forget to star LLMware and fork the repository. Also send it to your friends. We have a new bonus. We haven't announced it yet. We have the no code competition. It's going to be a big announcement on Monday, but go ahead and check it out now just for yourself, so maybe you can get ahead of the game. So thank you, everybody, and we will see you next